Let's chat about something that sounds like it's ripped right from a sci-fi script. Imagine Microsoft plunking down a whopping $100 billion on a supercomputer tucked away in the Arizona desert. This isn't just any tech gamble. It's part of their massive investment in OpenAI. They're calling this mysterious venture Stargate. So why is Microsoft betting the farm on this? Well, it's all about pushing AI into the realm of superintelligence. Yes, superintelligence, like the kind that radically transforms everything from how we work to solving problems that seem insurmountable today. Now, I know $100 billion seems like an astronomical figure, especially when the trend in AI is speeding toward more efficient, even thrifty solutions. It makes you wonder, is this just a flashy way to burn cash, or is there something more profound at play here? This brings us to the big unless. What if Microsoft is on the cusp of breaking through with long inference AI models? We're talking about the kind of AI that doesn't just mimic tasks it's been trained on, but starts solving complex, unpredictable problems in ways we haven't seen before. These aren't just ideas on paper anymore, they might soon be our reality, and maybe, just maybe, we're not quite ready for it yet. Scaling laws have been a hot topic. Skeptics have doubted them, but time and again they've proven to be on point. These laws suggest that as AI models grow in size, their ability to understand and process language shoots through the roof. We're now hitting models with trillions of parameters, like GPT-4, Claude 3, and Gemini, big names that keep pushing the boundaries. So, why go bigger? It turns out that bigger AI models aren't just showing off, they're actually getting better and better. In simple terms, making these models larger continually improves their performance. For those a bit more into the tech side, there's something called perplexity, a key metric in training these models. As the models scale up, perplexity drops, which basically means the models get smarter. This relentless improvement with size explains why Microsoft is throwing so much into Stargate. They're not just gambling on AI, they're leading the charge towards what could be the next frontier of technology. It's about creating AI that doesn't just mimic human thinking, but enhances it on a scale we've never seen before. Perplexity is a fascinating concept, especially when it comes to how we understand AI's language abilities. Let's break it down into simple terms. What is perplexity? Think of perplexity as a measure of a language model's confusion. When an AI, say a chatbot, tries to predict the next word in a sentence, its level of certainty or uncertainty in making that prediction is what we call perplexity. If the model's guess is off, it's perplexed. It's unsure about its prediction. On the flip side, the more accurately the AI can predict what comes next, the lower its perplexity and the more confident it is. This isn't just academic. It has real-world implications. Lower perplexity means smoother, more natural interactions with AI. It's crucial for companies like Google, Microsoft, and others who are in a continuous race to make their AI systems better. These companies invest heavily in lowering perplexity because a more confident AI is more useful and can handle more complex tasks. And speaking of investments, these tech giants are pouring money into technologies that can help reduce perplexity. This is where those massive data centers come into play. For instance, Microsoft's investment in their new project isn't just about having more computing power, it's about leading in an area where Google currently dominates. More computing power can potentially mean lower perplexity, better AI, and a stronger position in the market. Do they really need $100 billion? Now, considering the recent advancements, some might argue that investing $100 billion seems over the top. But if Microsoft aims to surpass competitors and set new industry standards, this massive investment could be their ticket to taking the lead. It's a high-stakes strategy in the competitive world of tech. Lately, every new AI model seems to be embracing something called a mixture of experts, or MOE for short. It's a fascinating approach where instead of one giant network trying to do everything, the system is divided into several experts, each specialized in different areas. Imagine having a team where each member is an expert in a different subject. Way more efficient than having one person trying to master everything. Here's where it gets really interesting. Traditional models are like juggernauts, massive and powerful, but somewhat clunky and underfit for specific tasks. They use a ton of resources for every prediction. But with MOE, it's like having a sleek, specialized team. Each router in the model decides which expert handles the task at hand, meaning only a fraction of the model's capacity is used at any one time. This not only saves a ton of computational power, but also cuts costs dramatically. Let's put this into perspective with an example. In the Mixtral 8x7b model, out of 8 experts, only 2 are activated for each prediction. This activation means that although the model has 45 billion parameters, only about 12 billion are in use at any given time, slashing the operational cost and size by nearly 3/4. It's like having the power of a supercomputer running on the energy of a laptop. There's another big plus. Since each expert focuses on specific tasks, they become really good at what they do. It's like each part of the model goes through intense, focused training. This leads to more precise, effective outputs and a lower chance of what's called knowledge collapse, where too much information leads to poor learning. But it's not just about being more efficient. This shift is guiding us toward a future where AI can be both powerful and economical, opening up new possibilities for integrating AI into more areas of life and business without the enormous costs typically associated with cutting-edge models. Typically, AI parameters, these are the bits of data that the AI uses to make decisions and learn, take up a decent chunk of memory. We're talking 16 bits per parameter, which allows for pretty precise values. But here's the kicker. It turns out all that precision might not be as crucial as we thought. Microsoft is leading the charge into what could be a revolution in AI processing by showing that reducing each parameter to just 1 bit, a simple 1 or 0, doesn't really hurt the model's performance. Imagine that, slashing data requirements down to the bare bones and still getting the job done. By switching to 1 bit, the whole process of how AI calculates things simplifies from complex matrix multiplications to straightforward additions. This not only speeds things up, but also slashes the computational load dramatically. What's more, this could mean we move away from needing specialized hardware like GPUs, which are currently AI workhorses. This isn't just about making AI smaller and faster, it's about making it vastly more accessible. Cheaper, less resource-intensive AI could mean broader adoption in industries that previously couldn't afford these technologies, potentially democratizing access to powerful tools that were once the domain of tech giants. And Microsoft isn't alone in this. Researchers across the globe are questioning the need for heavy-duty AI models that have dominated the scene for the last 7 years. They're exploring ways to make AI leaner without losing its edge, challenging the very foundations, or the status quo, of what we think AI needs to be effective. Traditionally, models like transformers have been the A-listers in AI. They use something called an attention mechanism, which lets every word in a sentence check out every other word to understand the context better. Super useful, but also super greedy in terms of computational power. Here's where hybrids come in. It's like tech smoothie time, blending the best bits of different tech. These new hybrid models mix old-school attention with newer, sleeker methods that don't need as much juice. A model called Jamba is a great example. It pairs something called Mamba operators with attention and even throws in a dash of mixture of experts. The result? It's just as sharp as the old models, but doesn't burn through resources as fast. This isn't just tweaking, it's a complete overhaul of how AI models operate. It means getting the same, or even better, results without the hefty resource tag. Imagine running a high-powered AI on something as simple as your home computer. That's the kind of leap we're talking about. And it's not only the software getting smarter, the hardware is also getting a revamp. New kinds of chips and systems are being built from the ground up just to run these types of AI more efficiently. It's like getting a new engine that's tailor-made for hybrid cars. What's exciting here is how this could change who gets to use AI. Lower costs and lower resource needs could mean small businesses and even hobbyists could start doing things that only big tech companies could do before. We're looking at a more inclusive, more creative future with AI. Ring Attention is a new distributing computing architecture that's all about efficiency. By cleverly partitioning sequences across multiple GPUs, it tackles the major hurdle of memory bottlenecks on devices. This means we can now train and run AI models with incredibly long sequence lengths, something that was a big challenge before. Thanks to this tech, some of the latest models, like Gemini 1.5 and Claude 3, are sporting million plus context windows. These aren't just numbers, they represent a massive leap in how detailed and nuanced AI understanding can be, all thanks to ring attention. But here's where it gets even more interesting. We're moving from a world where AI training time was the focus to one where the inference, how long and how well an AI can think through a problem, is key. It's like letting the AI marinate on a problem, giving it time to churn through ideas and improve its answers. Evidence from big names like OpenAI, MIT, and Google DeepMind shows that when models are allowed more time to iterate and explore during inference, their performance doesn't just get better, it skyrockets. For instance, GPT 3.5 outperforms GPT 4 in setups, where it can iterate its responses in what's known as agentic workflows. Kind of like how you might take your time to think through a tough problem. However, there's a catch. This kind of deep thinking AI is pricey. Running these sophisticated models with the freedom to iterate and explore is resource intensive, making it a costly affair. Yet despite the expense, the pursuit of these advanced capabilities is relentless. What happens when AI starts thinking like a human, especially in high-stakes environments like programming competitions or solving tough mathematical theorems? Let's explore some of the most impressive AI models that are doing just that. One standout model is AlphaCode 2, running on the Gemini 1.0 framework. This AI has hit the 85th percentile in competitive programming contests, which is no small feat. But there's a hitch: it's incredibly resource intensive. For every problem, AlphaCode 2 doesn't just try one solution, it generates up to 1 million possible answers and then uses sophisticated techniques to sift through these to find the best one. It's like throwing a wide net to catch one fish. The downside? This model burns through computational resources at an alarming rate, making it too costly to deploy broadly. Imagine every problem requiring 1 million tries. The compute costs stack up quickly. Then there's AlphaGeometry by Google DeepMind, which uses a search algorithm to explore possible solutions to geometric proofs. It's like watching a smart explorer finding the best path through a complex maze. If it hits a dead end, it backtracks and tries a different route, enhancing the chances of solving the theorem in smarter, simpler ways. So how does this tie into something like Project Stargate? OpenAI's work, especially with models like Q-Star, shows a similar trend. These models excel in areas requiring deep mathematical thinking, pointing towards a future where AI might routinely outthink us in specific domains. This all boils down to what we call System 2 thinking in AI, a slow, deliberate process that mirrors human reasoning. Today's models, like humans, can rush to respond quickly. That's System 1 thinking. But the real magic happens when they slow down, consider multiple angles, and compute deeply, just like we do when faced with a tough problem. Google's recent research introduces something called mixture of depths, which lets models dynamically allocate how much compute power to use per prediction based on the complexity of the task at hand. This could be a game changer, making AI not only smarter but also more efficient. Okay, so Microsoft is putting down some serious cash. But here's the thing, this isn't just about having money to burn. There's a vision here. It's not about creating another large language model that's a bit faster or a bit smarter. It's about pushing the boundaries, about creating something that could fundamentally change how we interact with technology. And let's be real, even the coolest AI models like GPT-4 and Claude 3 are starting to show signs of slowing down in terms of groundbreaking improvements. Claude 3, which came out 2 years after GPT-4, is only marginally better. It's like, where's the big leap forward? So back to that big question, why Stargate? It seems Microsoft might be aiming to leapfrog from long training times to long inference capabilities. Imagine AI that doesn't just respond instantly but ponders, iterates, and evolves its responses like a human would when faced with a complex problem. This could be huge. We're potentially talking about AI models that do more than perform tasks. They could start solving problems in ways we haven't even thought of yet. That's not just a step forward. That's a giant leap into what future tech could look like. So, what do you think? Is Microsoft on the brink of something revolutionary, or is this a massive gamble? Either way, the implications of what Stargate represents for the future of AI are enormous. Got thoughts on this? Drop a comment below. I'd love to hear what you think about this big move by Microsoft and what it might mean for the future of AI. Don't forget to like and subscribe for more deep dives into what's happening in tech.